So this is an old test from maybe 2017, 2016. This is an 80-point version. It was all multiple choice. There is no 80-point version. For y'all, there's no 80-point version. There are no hints whatsoever. Okay? I don't care who you are, no hints. But this is a calculator hint video. A question like this is not so bad. It's not. You'll get partial credit for a decimal. Okay? Some of these are multiple choice, some of them aren't. But the cosecant of 10 pi over 3, somewhere on your form quizzes, you're supposed to know the cosecant ratio is a whole, or it's 1 over sine. Now you are going to have to take whatever's given and convert it to a degree. So for this example, you're going to take 10 pi over 3 and you're going to multiply it by 180 over pi. And you're going to get 600 degrees. It's going to be 600. So if you don't know how to do this drawing that I've done in class, if you don't know 30, 60, 90 theorem, whatever, you can just type 1 over sine of 600 degrees. Now, if it's multiple choice, easy peasy Japanesey, right? 1 divided by the sine of 600 is going to return a nice, well, not a nice answer, it's going to return a decimal. Probably either a half or root 3 over 2 or something like that. Okay, this one's root 3 over 2 or something like that. It returns negative 1.154. So there's your decimal. Negative 1.155 is partial credit. But if it's multiple choice, you can just type things in. I feel like it's probably this guy right here because it's got a root 3 in it. The original thing was pi over 3. That's kind of how it works. Negative 2 root 3 sitting pretty over a 3 is that thing right there. So there you go. That's how you do something like that. Tangent of 11/13 pi over 4 is ridiculously easy. You're going to convert that into a degree. You're going to multiply it by 180 over pi. And you're going to get 1345s, which is 450. I want to say it's 585. It is. It's 585 degrees. So I'm just going to press tan 585. It's a 1. I guess you'd get full credit on that thing, wouldn't you? I guess you would. All right, using reference angles, find the secant of negative 210 is the next thing I see. This one, even for them, was not multiple choice. It just wasn't. So the secant ratio, in addition to being funny, because it's ha, is also 1 over cosine. So I can just do this with a ratio. I can just change it to a reciprocal. So I could do 1 over the cosine of 210 degrees. And again, this will get you partial. It will. It'll get you half credit. 1 over cosine of 210 is this thing right here. It is negative 1.155. Now, by the way, I've done these for a long time. I actually had an hunch that this is what it would be. But you'll notice on the previous one, things you can do with is you can play around with your multiples of root 3s and 2s. You can do that. Maybe you can reverse engineer the radical. I don't know. But this one is negative 2 root 3 over 3. But this is half credit. And this would be full. But generally speaking, if you want the full credit, you usually have to draw. Easy peasy. All right, number 16 can be done entirely in a calculator. You do not have to draw. Evaluate the arctangent of negative 5.1 such that the angle lies between 0 and 180 degrees. The thing is here is you need an argument, all right? So it's really that theta is the arctangent of negative 5.1. And this is not something you can put in a calculator. It doesn't work. You can't put it in a calculator. Because the arctangent function only returns one answer. That's part of the issue. Now this one's not a big deal. It's only got one answer, but whatever. All right, so what am I going to do here? What I'm going to do is I'm going to write the inverse. The inverse is really easy. This was output, now it becomes input. And input becomes output. So negative 5.1 equals the tangent, because the inverse of arctangent is tangent of theta. And then I can y1 and y2 this thing. Now notice that limitation up there. That's x min, that's x max. I'm going to play with my window, and we go from 0 to 180 degrees. And again, you need to make sure your calculator is in degree mode. I am teaching you guys degrees. And I'm going to hit graph. And there's an answer. There's an intersection right here on that interval. Second trace 5, enter, enter, enter. Maybe. There we go. I had to get the cursor there. You have to look for the cursor sometimes, kids. That's just the way it is. Enter, enter. There she is, 101.09 degrees. So I got that theta is 101.09 degrees, which is choice C. I didn't draw. I gained it. This one can be done with a TI-84, such that 0 pi is less than 2 pi. So 0 degrees to 360 degrees with the same methodology. So the idea here is if theta is the arc cosine of negative root 3 over 2, then, and the equation I can use, negative root 3 over 2 is equal to the cosine of theta. Same kind of setup as before. And I've done at least 2 of these in class with every student I've got. Now we're going to play with the window here. This one is 0 to 360. So 0, 360, graph. And we should see 2 answers. And we will have to convert these back to degrees. Second trace 5, enter, enter, enter. One of the angles is 150 degrees. Second trace 5, enter, enter, enter. And the other angle is 210 degrees. And then what you do is you convert them back into the pi rads. So you do 150 times, what is it, pi over 180? And I reckon you would get 5 pi over 6. There's a 5 pi over 6. There's a 5 pi over 6. But there's 2 answers, right? Not that you have to do this now, but 210 times, and I'll probably make this multiple select with y'all, times pi over 180, and you would get 7 pi over 6 when everything is said and done. So it's choice C on this test, but this is not your test. This is an old test. I'm just showing you things you can do on the calculator. It's quick too, it really is. All right. What is the sine of theta if the tangent of theta is negative 2 and theta lies in quadrant 4? There is a way to cheat on this. What you can do is you can find theta. You can find theta. And you can do it with graphing. So quadrant 4 means that the angle lies between 270 degrees and 360 degrees. So 270 degrees is less than or equal to theta, less than or equal to 360 degrees. This would be my x min, and this would be my x max. So I'm going to put that into y1, I'm going to put that into y2. And what I'm doing is I'm finding the angle. I'm finding the angle. And I don't know if this will be any easier on you or not. I don't. It makes sense to me, although it'd be quicker for me to graph it. It would be. Or not graph it, but to draw it. But whatever. You're not me. The window needs to be adjusted from 270 to 360. Hit graph. Because that ensures that this angle I get back is in quadrant 4. Second trace 5, enter, enter, enter. And what I just learned was that theta, or my x value here, is 296.57 degrees. That's what she is. All right. Now, the original question is, what is the sine of that angle? Wasn't it? That was the original question. So I'm going to find the sine of 296.57. I'm just going to push the button in the calculator. Oh, by the way, we're under a tornado watch, and I'm up here doing math for you. I am. I really am. Negative 0.894. You know, if this was a test and you gave me the decimal, you'd get partial. So this again is partial. But how would I know? Because I'm not going to look at your friggin' test. Unless I think you cheated. But I'm just going to type in answer choices. It's obviously not that one, because that one's positive. Maybe it's negative 2 root 5. Root 5 is a little over 2, so a little over 4 divided by 5. This makes sense. It does to me. And it is not negative 2. Oh, actually, no. This was rounded. So this is even more rounded. That's pretty stinking close, isn't it? Choice D. And I think that's it for the calculator hints. I don't know if that's going to help you or not. Everybody learns things a little bit different. Everybody has preferences. Some of y'all still don't know where the pi key is in the calculator. So it is what it is.